Hello all, welcome to SECOORA's second webinar of 2018. Thank you for sharing your lunch hour with us. We are hosting this webinar series to discuss, highlight, and raise awareness about coastal ocean observing in the Southeast U.S. My name is Abby Wakely, SECOORA's Communications Director, and I will be facilitating and moderating the webinar. All participants will be in listen-only mode. You are encouraged to type questions for the presenter or technical questions in the bottom left-hand chat box. I will respond to them directly or post the questions to our presenter after their presentation. We are recording this webinar today and will be posting the recording along with the PDF of the presentation on the SECOORA website. We are very, very excited to welcome Stacey Buckelew from Axiom Data Science as our speaker. She'll be presenting Next Generation SECOORA Data Portal. Stacey is the Director of Programs at Axiom Data Science. She engages with scientists to support their use and organization of Axiom's data portals and data management tools. Stacey has a 10-year history working in applied marine ecological research and coastal habitat restoration in locations spanning literally from the Arctic to Antarctica. Through these experiences, she has a well-developed capacity to coordinate across research teams and stakeholders to support their decision-making needs. Stacey, thank you so much for joining us. You can go ahead and share your screen.
Great.
And I just want to confirm that I do see your screen.
Okay, super. Well, good afternoon, everybody. Thank you today for joining us to learn about the SECOORA Data Portal. I'm joined today by Brian Stone, who's the lead developer for this project with Axiom Data Science, in addition to Kyle Wilcox, who many of you probably are familiar with as the data management lead for SECOORA. We're excited to share with you this next generation version of the portal, which currently is available in a testing environment. It was developed by Axiom Data Science in partnership with SECOORA. This version includes new feature enhancements as identified by feedback from many of you and other end users. And today I'm going to start with a high-level overview of the portal, showing you some of the features, a little bit background information, and then I'm going to hand it over to Brian, who's going to do a live demonstration of the portal and walk you through some examples. I'd be a little bit remiss starting without a story. And if you look at this graphic, you might think this is a story about my career. And that's probably true, but more this is a story about data and data evolution. The amount of data that's being stored has grown exponentially over the past few decades. I think we're all aware of this, and this is predominantly due to the explosion of technology and social and digital media. The IDC estimates that the volume of digital data is growing about 40 to 50% per year, and by 2020 globally we'll reach about 40 zettabytes of information. Most of this information is being captured in social and digital media. However, scientific data is not immune to these trends. And recent research suggests that scientific output is doubling about every 9 years. And because of this massive explosion, we are witnessing shifts in how we're thinking and handling this rapid and high rate of data production, or big data as it's become to be known. This massive growth of data is quite staggering and reforming data management and, as a community, how we are governing data. And this has implications for data storage, data architecture, and the design of databases, since the way that we capture, store, analyze, and even distribute the data is transforming. And this explosive increase in data is seen as a game changer in a lot of scientific research, as it promises new ways to produce knowledge. Large data is certainly nothing new for science and has long existed with supercomputers in some scientific fields. But what's new is the way that open data is being emphasized as crucial to excellent and reliable science. And we're shifting more towards integration, visualization, and dissemination as tools for science and not just byproducts of science. And the reason I'm telling you this background information is that these elements of big data are really what's driving the development of this data portal for SECOORA, as well as other data portals developed by Axiom. Ocean data we consider is big data, particularly when attempting to couple heterogeneous data types from many different sources. The ocean data that we're interacting with amounts to tens of thousands of stations that are creating millions of observations weekly. This portal is developed as a partnership with Axiom and SECOORA. And to handle this large volume of data at Axiom, we have adopted a shared infrastructure approach to leverage applications, data systems, and hardware across a number of partners, IU, NOAA, and other national and regional partners. And under this model, functional improvements funded by one partner can be shared across the collective to accelerate progress. We also utilize community-developed software and protocols for interoperability and to standardize systems and interfaces across partners. And the infrastructure that we use, these photos show our data center in Portland, is a scalable compute and storage infrastructure to keep pace with the growth of data and data availability. Using this approach, we've developed the next generation SECOORA Data Portal, which currently it's available in a beta environment as we test capabilities with users like you to get feedback and to identify what changes or functional improvements need to be made. We appreciate the work that's been done by both Jennifer and Abby with SECOORA to help outreach this beta environment and connect with a lot of you individually. And this version will be operational in April of this year with continued optimization enhancements made for beyond that. We consider this to be a data environment rather than a data system to adapt and grow with new data as it becomes available. And with this portal, we're really trying to solve three things: to make data discoverable, to allow users to access data, and to allow users also to visualize data for interaction. The SECOORA Data Portal has three main capabilities. There's a data catalog, which existed in the current or the older version of the portal that you should be familiar with. This allows users to search, discover, and download data. There's also a map-based interface in the portal, which allows users to visualize and integrate data across many different data streams. And perhaps what's most new in this version of the data portal is what we're calling data views or data dashboards. And these allow users to rapidly assimilate data and integrate these into comparison charts and apply on-the-fly summary statistics and comparison charting. And Brian's going to walk us through some of these later to give an example. Just a quick look at how we're ingesting data into the portal. We're using sort of this data pipeline, if you will. Data is ingested into the portal from distributed data resources into this data environment or data system using web-based services such as ERDAP or one-off data files that are submitted by a data provider. We use a standardized approach for automating the capture of data, quality reviewing it, and storing and standardizing the data in our internal services. And then applying some transformations to data and metadata through various geo-servers or other custom services to provide these front-end visualizations and analysis that are available through these publicly facing information products, both data portals and Jupyter notebooks, which I'll also mention. And it's through this approach that the portal is able to integrate heterogeneous data types from multiple different sources, platforms, various locations, model data, biological data, glider data into a single system that's available for use by researchers and other end users. And this data is scalable to hundreds of thousands of sensors and other data types in a single platform. I'm just going to walk you through the various features or capabilities of the portal that I mentioned and just give you sort of a quick overview and sort of how-to, if you will, on how to use some of these features. So the data catalog, as I mentioned, is available to search and discover data sets. There are lots of different data types available within the catalog. And we've tried to organize it in a way that data can be discoverable through different ways, given that people have multiple ways in which they're looking to find data. You can browse through the data catalog, or using a search box, you can type in key terms to narrow those data sets. We have filters available to filter data by thematic tags, or you can filter by data type, real-time sensors, data layers, moving platforms. It's also helpful to know that under the advanced search options, you can apply a spatial feature to look for data or look for various time or access controls. Within the data catalog we've reworked a bit in this next generation version. Each data set has its own content page. At the top of the page, there's a summary and metadata for the data set. And within each data layer, there's a variety of visualizations or data layers that may be available. In this example here, we can see that there's 7 data layers available for the Florida Fish and Wildlife Management. Within each of these, there's a map data layer, and more information is given about the metadata, the spatial extent. And here a user can choose to add the layer to the map, sort of queue up data layers like a shopping cart, or access the data through downloads. Each data set has download links to access the data using various interoperability services. If the data is gridded, it can be downloaded as threads or Nets PDF. If you're building another web application, you can download using NCWMS. If the data set you're looking at is vectorized, you can download the data as shapefile or CSV. In addition, a lot of our data sets are available through National IUCE Catalog, or Sensor Map or data is also available to download via ERDAP. And for each data set, user can download the data file directly or connect to data access endpoint. Data layers can be queued up into the map for visual interaction. This example here is showing a real-time sensor layer through the data portal. There's about 300 real-time ocean and coastal stations across the Southeast region. The visual summary for individual stations are grouped into adjoining polygons and colored to show a heat map of the latest conditions for the selected parameter. In this case, we're looking at air temperature. In many cases, there are multiple sensors available at each station, so within those polygons. And users can filter the data set by sensor types using the filters on the right to see the various sensor parameter types that are associated with each station. To give you an example, with this layer, there are about 1,500 sensors that are reporting 35 different data parameters that are available across about 20 different data providers. So in total, it's about 500,000 sensor observations that are reported weekly through this data layer. Just to familiarize with some of the features, you can filter by sensor type, by source provider. Users can use key terms to enter a station name or a location. We also have a time filter where users can scroll data back in time. With the real-time sensor, there are observations that are dating back to 1994. And we also have a depth filter. So for stations that have a depth element, you can quickly filter and explore those. Within the map, you can hover over a polygon to get real-time conditions for the selected parameter. In this case, again, we're looking at air temperature and when the latest observation was taken. So that's the real-time observation there. As I mentioned, this map is a bin aggregate of more than one station that's available within each of these polygons. And the number of the stations are shown within this hover feature and also summarized by provider, in this case, NOAA co-ops and the weather service. To see individual stations, users can zoom in to dissolve the heat map into individual points. You can hover over a station to see real-time conditions for individual stations. So here the real-time conditions are shown. In addition, you can see the other sensor types that are available for that station. And clicking on a station will open a data chart for that station that shows the entire time series of the particular sensor. So in this case, we're looking at data from 2015 to 2018. The graph shown includes a mean of the sensor observation over time in addition to min-max values. Charts for the other sensor types that are available for that station can be selected using a drop-down menu. And again, a slider bar can be used to zoom in on the time scale and look at smaller time intervals, or custom dates can be applied using a date bounding control. Users can also download data or navigate to station or source metadata pages, or there are some options to customize the chart legend. I mentioned that there are many different data types available in the SECOORA Data Portal. At any time, you can revisit the catalog and add additional layers to the map. You can use this using the search bar or navigating back to the catalog to queue additional layers into the map. In this example, I'm just showing more than one data type that's visualized to give you a sense of those capabilities. This layer shows a long time series manatee mortality data set. The data set dates from 1974 to 2013. The individual mortalities are summarized into adjoining polygons. I've also added to the background a satellite sea surface temperature model. I can use the filters on the right to explore the different measurement types or data categories for manatee mortality. I can also mouse over a polygon to get a quick summary of the number of mortalities in that area. Because this is a heat map, I can easily identify trends in the data and zoom into areas that might be particularly interesting. To do this, there's a polygon tool that I can draw around an area of interest, as shown here, to generate a summary chart for that spatial area. So here I'm looking at a histogram of mortality within that area. A limitation of the earlier version of the portal is that you were only able to visually explore 2 layers stacked together without the ability to do any more detailed comparison or comparison charting. A new feature in the SECOORA portal is this new data view or data dashboard feature. And within the data views, you can rapidly assimilate data to integrate different data types into comparison charts with on-the-fly summaries and charting. And this really allows the user to have deeper exploration of the raw data to identify trends and relationships. And this pulls data from multiple sources with the ability to change and customize graphs. Users can save individual data types on the right-hand side and integrate those into comparison charts on the left-hand side. With these charts, users can apply different chart summary statistics, such as anomalies, climatologies, or various histogram charts. You can alter the temporal binning of data and interact with data sliders both on the X and Y axis and add custom time bounds similar to the data charts we saw earlier. In the comparison charts, you can queue up as many data types into these comparison charts. You have features to scale and group the data, additionally time bin and customize data charts. Within these data views, users can add custom text or links to provide a narrative or apply context to the data, a particular data scenario or data view. And once a user does that, they have the ability to save or share their work, since it can take some time to get these set up. And you can share that assembled view with any member of the public using a URL. And Brian is going to walk us through an example of how you as a user can make these data views. From the data charts, there's also the ability to download data. So if you want to apply further statistics, if you're a researcher, you want to download this data to your local machine, you can use interoperability to access that data, either the raw data or if you're looking at a bin data set, you can download it in that bin view as well. Before I turn over to Brian to walk us through some examples, I just want to give a quick mention of the other technologies that work to support the portal and data throughout its entire life cycle. For the portal, we've utilized an approach that applies custom services to manage data throughout the entire life cycle. This includes managing the flow of information from creation through use, reuse, and transformation. With the portal, we really are handling data in its later life stage, making it available for public access, discovery, and download through the catalog. Also, we're providing tools for the reuse and transformation of raw data accessed through the portal or the catalog through interactive data products, such as seen through the map, some of these summary statistics. We also have a feature where you can download the data and reuse the data for various syntheses using a server-side R and Python numeric workflows and Jupyter notebooks on any data that's available through the SECOORA portal. The capabilities for the SECOORA Portal are backed by additional data management capabilities to support the storage of data using a custom application we call the Research Workspace. We presented this to some SECOORA users last month. In the workspace, we also have capabilities to describe the data using a metadata editor and to archive the data using automated submission pathways. I just want to mention the Research Workspace really quickly. This is a custom application developed by Axiom Data Science that allows for web-based data sharing and collaboration among users. The Research Workspace sits behind the portal and helps migrate data into the data catalog for public access. And within the Research Workspace, we're also hosting Jupyter notebooks where users can download data from the portal and execute numeric workflows on data. They can execute those workflows on their project data alongside these publicly accessible data sets available through the portal. Jupyter Notebooks allows users to create and share documents that contain code, equations, and visualizations. These numerical simulations are reproducible or shareable among users, and again can be done on data uploaded through the workspace or accessed through the portal. And this is just a quick example of a notebook that was done for the Arctic Marine Biological Observation Network, and just a quick look at some more capabilities and visualizations done through notebooks. Before I turn it over to Brian, I just want to mention that we have help resources that are available. They are under development. If you're a user doing this on your own computer, you can access the help button up in the upper right toolbar and access our detailed documentation with information and steps on how to walk through. And this is something we're going to continue to be developing. So keep your eyes on this for improvements in the future. So that was just a quick walkthrough, and now I'm going to hand it over to Brian Stone. Brian Stone is the lead developer for the data portal, and he's going to walk us through a live demonstration and some examples.
Hi, thanks, Stacey. I'm going to share my screen. Okay, so this is the front page of the Next Generation Data Portal. Basically, I'm going to walk through some of the features that Stacey talked about and how to create them from scratch. So you'll recognize some of the data views and maps that she showed, and then I'll walk through searching for different data resources and adding them to a custom data view. So one of the big new features for this release was adding data views. One piece of feedback that we got from a lot of users and groups was, this is a cool product, but it's really hard to recreate views of map views or data views showing an interesting time series. So it might take 15 minutes or half an hour to remember how to recreate something. So we tried to make it easier to create these things from scratch, but also made it possible to share sort of a prepackaged data view with people. So that's here at the bottom of the screen. These are 3 different data views that we've created with the SECOORA team. We could add as many as we want here, but at this point we're keeping it at 3. So I'll click on this first one, which highlights Hurricane Irma. At the top of the screen, you can see that we've sort of added a brief description and a video showing a time-lapse satellite of Hurricane Irma. This is just HTML, so anything can be added up here, links to other resources, downloads, things like that. Further down, we've added different time series that we've pulled from the data portal. On the right side are the individual time series. Next to the label at the top of each time series is a number, and that corresponds with a point on the map. So this one corresponds with Key West, Florida. And then as I scroll down, I can see these different barometric pressure charts and wind speed charts. Within each chart, I have the option to download the data as a CSV, go to the station page for more details and other sensors from that station, go to a single sensor detail page that also gives more technical details about the sensor, or jump into the source. And this is actually where the data was pulled from. That wasn't a good example. But usually that goes to a live data source where we pulled the data from. At the top of the chart, I can click on, again, the sensor. That would take me to a particular station page. The source, this would show me all stations from that source on a map and give a list, a searchable list. And we'll go further into that a little later, or the station page. I can expand the chart. And within that view, I can hover or turn on and off different aspects of the chart. I could also zoom in and out of the time series. On the left side, we've pre-created a comparison chart that shows the comparison between barometric pressure and wind speed as the hurricane came through. So hovering over this time series, I can see this is Big Carlos Pass, which is near Fort Myers. As I hover, I can see the measurements for each time. And you can see that as the hurricane came through, the barometric pressure dipped, wind pressure went up, and then during the eye, the wind speed dipped and then came back up. Also on the hover window is a directional, showing the wind direction. Within the main chart, I get a full wind rows for the selected time period. As I scroll in and out, the wind rows update. You might also notice that as I zoom in and out of the time series, the time bin is readjusting. This makes it so that your computer wouldn't crash, so that we can show a lot of data. We can show up to 30 or 40-year data sets, while making it easier to see the data. If I were to zoom out and show all data, it would be difficult to pick out trends. I can still change the time period manually. Within the comparison chart, I can quickly change the visibility of these different sensors. So we can pile up as many time series as we want, and you can see that there's a barometric pressure axis and a wind speed axis. All right, going on to another data view. This one is Carolina water levels. So on this one, we've featured a webcam. This is a real-time view at White Point Squash, next to some historical data sets, or they feature long-running data sets. In this case, we've featured the anomaly chart type. This is calculated on the fly, so as I zoom in and out, I can explore the trend over time. I can, again, change time period, hover, and get details. Or I can change my chart type. This is climatology. Again, I can explore years. If there's a particular year of interest, I could link into that. And in all these cases, if I create a new data view and set up a chart in a particular way that I like, I can share it with another user. The last chart type is our line chart. This sort of includes all the different features. I'll walk through this really quick. I'm going to start by turning off all the, most of the line types. So initially, this is just the mean. We've binned on months. I'll change that to auto. So the chart would rather we bin on weeks. By default, as I zoom in and out, the bin size should change. So now it's days, and then as I zoom in on real time, it'll give me all data eventually. Zooming back out, I'll turn on the min-max envelope. So this is now overlaying the mean value for water level with the min-max envelope for each time period. Seasonal statistics, this is sort of the climatology feature. The pink area is the mean to 90th percentile. Blue area is mean to 10th percentile. And then I can add all-time highs, lows, and overall mean. And hover and get all those statistics again. On the left side, we're comparing the two water level sensors that we've selected, Beaufort, North Carolina, Wrightsville Beach, North Carolina, to see if there are any differences in trends. And I can zoom in and explore, again, on hover. Really quick, I'll run through the station level page. The source level page. This is showing me all stations from a particular source, in this case, the Long Bay Observation System. Some of these lists can get fairly long, so there's a text search available and sorts on the start and end date of data available from a particular station. I can click on a station and go to the station level page. Station level pages are available from a number of different locations, including charts. Any chart has a link back to the station level page. There are also searchable assets in the data catalog. This gives more information about the station that we're looking at, including the precise location, temporal coverage, what sort of platform, URN, that's of interest. One thing, a question came up earlier, what sort of services are available. In this case, we offer a CSV download or ERDAP data service. Using this URL, you can explore a number of different services and formats that ERDAP offers for each of the data streams, including CSV, JSON, GeoJSON. All right, so I'm going to jump into exploring the map and creating a simple data view. By default, the map will load up the real-time sensors. So from here, I could click on Explore Map or Map at the top of the page. Real-time sensors loads up. I can quickly explore a heat map for different sensor types. I can change this to barometric pressure. This is going to give me a heat map of most recent barometric pressure readings from stations across the region. If I hover, I'll get either mean value if there are multiple stations represented within the hex cell, or the value, the most recent value for the station within the hex cell. I also get an overview of what sorts of stations are available from what sources. If I zoom in, I can quickly explore different data sources. I forgot to do one thing I was planning on doing. I'm going to set the time slider to real time. Right now, this time slider is showing that I have one layer loaded that is time enabled. It's available from July 13th of 1994 until today. I can reduce this using a quick control to past 5 years, past year, past half year. I'm going to select real time. So that does a couple of things for me. It hides all stations that don't have real-time data. In this case, every station should have real-time data since I've loaded up the real-time sensors layer, but other layers don't have that. It will also load up by default real-time data. So it's not going to load up the full time series initially. So this is barometric pressure at a NDBC buoy off the coast of Charleston. I'm looking at barometric pressure. I can hover, get details, change sensor type, and again, I can expand this out to the full time series. Okay, so this particular sensor is of interest to me, so I'm going to create a new data view. You'll notice that the data views that were loaded by default aren't available here. Those are locked. So those are shared data views that I can't add to on the fly. I would need to create a new data view. So I'm just going to call this test webinar data view. And I'll save this time series to the data view. At this point, I could also add it to the comparison chart. And I'll click on one more station. So we'll look at air temperature here and add it to the data view. I can now click on the data view that I've created. Again, I can explore. And at this point, I could share this with people by clicking on the share link at the top. I get a unique URL that I can tweet out, send somebody, whatever. I can quickly add to the comparison chart. And then again, I'm interested in real-time data, so I'll zoom that in. And I can quickly add a description. And if I know some HTML, I could add that too. So that shows up here. Any notes that I put at the top, any links would be shared with users if I were to share this URL. Okay, so now I'm going to head back to the front page and explore the catalog. So the catalog link is at the top of in the top bar. It's available from any page. All right. From the data catalog view, I can browse results. So right now, this is a mix of data layers, sensor stations, and moving platforms. I turned off moving platforms earlier. I'll turn that back on. I can quickly explore different categories of data layers. I can do an advanced search. So if there was a particular area of interest, I could draw a polygon. Right now I'm getting mostly sensor stations that are available within that, sorry, it wasn't a polygon, it's a bounding box. Within that bounding box, plus a few data layers that overlap that bounding box. Or I can do a text search. So I'm interested in sea surface temperature. So from this window, I can hit enter and perform the search, or I can do this, a quick search is performed, and I could quickly add these layers to the map. So I'm interested in this particular sea surface temperature module. Within the module, layers are available, sea surface temperature and sea ice area fraction. Since we're looking at Florida, I'm going to avoid sea ice. And I'll add this to the map. You'll note there's also a downloads button. And for this particular layer, a WMS web mapping service is available. You can copy this link out, use it in your own map, Jupyter Notebook, whatever. So now that I've added this to the map, I can go to the map. Real-time sensors is still available. I'm going to hide that. And I'm going to change my palette. So I did that by clicking on the actual palette in the menu. And then if I click on Auto Set for Data in View, the backend will quickly figure out the min-max bounds for the data that I'm looking at. And it just highlights, you can see trends a little easier. On hover, I'll get a quick estimate of the value where my mouse is. And then if I want a time series, I can click. Since this is a long time series, the climatology chart is available. So this is the same chart we looked at during the Carolina water level data view. Again, I can change chart type, zoom in and out. Expand, download CSV, the same time bin features are available. In this case, I'm going to add this to my data view and add it to the comparison chart. If I go to back to the data view, it's at the top, and here it is in the comparison chart. So a new axis has been added on the right side, water temperature, and it's overlaid against my real-time sensors. All right, so now I'm going to add a new type of data, biological feature-based data. So we'll look at the manatee data set that Stacey demonstrated or showed pictures of earlier. So from search results, I can quickly add to the map, quickly jump into downloads, or I can click on the header and get a more detailed view. So this gives me more information about each of the manatee layers within this module. I'm particularly interested in the manatee mortality layer. So it's now been added to the map. I'll go back to the map. I'm going to, for now, hide my sea surface temperature layer. And again, change my palette. So I can do some quick time exploration here. So now you can see we have 3 data layers loaded up. I can hover to see the time extent for each. In the case of real-time sensors and manatee mortality, it's a bracketed time span. So it's all data within the time period is going to be, within the bracketed time period is going to be shown. In the case of the sea surface temperature, a single slice is shown, and that's why there's a single dot. So it's hidden right now, but right now we're showing February 25th. So I can do some quick exploration. This doesn't translate that well over webinar, but if I slide the time bar, my map will quickly update. So I can start to pick out trends. I can quickly explore data within the hex. Since I've since I've reduced my time period, only data for the time period selected is shown. Under this hex, we're seeing that there were 73 manatee deaths There's a breakdown by sex and mortality type. The breakdown is also available within the legend. So if I'm going to expand my time bar out again. If I'm only interested in, canal lock deaths, I can quickly reduce my heat map. Okay, I can also quickly explore using a polygon tool. So this allows me to select arbitrary bounds and I'll get a time series of data within those bounds. I'm particularly interested in the East Coast. And then I quickly get a histogram. Again, I can hover and get the full breakdown of data. And then I can quickly adjust that and my histogram will update. I'm going to take this all the way down the East Coast. All right, so I'm noticing a spike of manatee mortality in 2010 to 2012. If I zoom in further, the chart will rebin and I can see that the spike is more concentrated in the winter of 2010. Looking at the breakdown, the cause of death seems to be mostly cold stress. So luckily I have a sea surface temperature layer all loaded up. I'm going to bring it back into view. Since the time period of interest is winter of 2010, I'm going to adjust my time slider here for the sea surface temperature to winter of 2010. And again, auto set for data in view. And then I can click and get a quick time series. Okay, so we're particularly interested in the 2010 period. Given this chart, it's a little bit difficult to pick out a particular trend. You can see that the mean dips pretty low there, but this would be clearer using the anomaly chart. If I hover over that time period, you can see that that's a particularly cold, in particular March is very cold during that year. 4 degrees Fahrenheit below the mean, the average mean. The mean. Okay, so this seems like a good candidate for a data view. I'll create a new data view. And I'll bring up my histogram again, add this to the data view. So since I've selected an anomaly chart, I can't add it to a comparison view. So I'm going to switch back to line quickly, add this to the comparison chart, add my histogram to the comparison chart, and then zoom in on my area of interest. And you can see that my spike in mortality occurs near that dip in temperature. So that's something that I could download the data and investigate further. This is sort of a simple biological layer. I can also, there's a number of biological indice data layers that I'll quickly demonstrate, and then we'll look at one more data type and get to questions. So this is the StimMap data set. Load this up. We've got quite a few layers loaded up. I'm going to hide manatee mortality. sea surface temperature. And then I can quickly zoom to the extent of the map. I clicked on the little magnifying glass. This layer has a number of different measurements available, different biodiversity indices. So I can quickly explore those. And this is a depth-enabled layer, so I can filter on depth. And the indices will be recalculated. I can get a quick overview on hover, or again, draw a polygon and add to a data view. I'm getting a breakdown by species here per time period. Finally, I'm going to go back to the front page, click on this glider deployment link. Something is a little off with search right now. Okay. This gives us a list of gliders available in the system. I can, again, quickly click on download, see services available, or go to the visualization page. I get a 2D map view on the left side, a 2D curtain plot on the right side, and a 3D view at the bottom. If I hover, the point is I get a quick profile of the depth plot. The location that I'm at is highlighted on the map and in the 3D plot. I can change what I'm visualizing on, 3D plot update, and I can zoom into a particular segment of the glider. Downloads available. From here, I could quickly create my own plot in ERDAP. I did that ahead of time, and this is what I came up with. It's fairly simple to create that, but it takes a few steps. Okay, I think we wanted to leave a few minutes for questions.
Yeah, thanks so much, Brian. So we do have a few questions. The first one comes from Dave Jones, and I think you answered this, but if you could just repeat your answer. He asked, will you be serving web services, web map tiles, KML, JSON, REST services, feature services on the website or on the data portal?
Yes. So this is a new feature from Search. You can now get to many of those things. Depending on the data type, I'll start with data layers. I can get WMS, WFS, a few different JSON. Anyways, you'd have to explore to see what all is available. I can also filter on access methods. So if I'm particularly interested in WFS services, I can filter on that. OpenDAP threads. Okay, shapefile, CSV. Station sensors also have a number of different services available, ERDAP and CSV download. Most of those work as services that you could use from a system like a Jupyter Notebook or a web map.
Great. Thanks so much, Brian. And if you all have any questions, you can type them in the bottom left-hand chat box, and I'll pose them to the presenter. And then we have another question from Mary Neely. She said, during the development, was there any coordination with other existing program data portals, example, other regional associations, to build similarities or utilize common appearances or syntax?
Yes. So this was built with AUSE, Senkust, and IUSE all taking part. So, Stacey, you might be better suited to answer that question.
Sure. I think this goes back to sort of that shared cyber infrastructure approach I mentioned at the onset, where we're leveraging sort of a base data system, if you will, and customizing it for different regions or partners. We're using a similar platform to develop a national sensor map in addition to providing data management support for Alaska Ocean Observing System, Central and Northern California Observing System, as well as SECOORA. And through that, we're getting a similar look and feel for sort of the front end or user portal interface to leveraging our back end system and sort of that data pipeline that I mentioned, in which we're ingesting and creating these pathways for handling and storing data internally. And the benefit of that is that sort of one development piece that's funded by one partner is going to help the collective and advance, data features or functionalities within their particular region.
Great. Thanks so much, Stacey. I have another question from Marie. When she saves the dashboard and exits the portal and then returns to the portal, does the customized dashboard remain and keep aggregating data, or will she need to bookmark that personalized link?
So the safest way to make sure, I think she also asked if 30 days from now it would still be available. So the short answer is yes. Every time you reload, you're going to get what you had as long as you're on the same machine. So right now we don't have a login system. In the case of 30 days later, I would suggest you bookmark that data view using the share link, just because who knows if you're going to clear your cache on your browser or whatever. Sort of on the roadmap is to create a login system. Right now, that's not available.
Great.
One other note I wanted to make was in the upper right, there's this little red bullhorn. Click on that if you would like to submit feedback. The nice thing about this is we'll see exactly where you are on the portal. So if you have a question or something isn't working, we can kind of recreate what you're doing and get back to you, and usually fix it.
Awesome. Thank you, Brian. And then another follow-up question from Marie is there any storage of high-definition video or still camera shots in the SECOORA data catalog?
We can. Right. I was going to say we can store and show those webcam shots as well as live stream feeds in the SECOORA portal. Brian, I don't know if you want to further that at all.
Yeah, I was just going to say I showed one of the webcam locations. We have one other. If people are aware of different webcam locations, those can be added to the portal.
Great. Thanks, Brian and Stacey. And then seeing that it's 12:59, I'll ask one more question. And if we didn't get to your questions, I'll ask them directly to Brian and Stacey, and they'll follow up through email. For Marie again, can you turn off data QA/QC and just view the raw data?
So the easiest way to do that at this point is to just download the raw data. Depending on parameter, we are doing some light QA/QC, and on the roadmap is to add that as a sort of advanced feature where you could visualize points that have been removed or visualize just the raw data.
And furthering on that, so right now the SECOORA can pull in the external quality data, and then if we're in the process of developing the capacity to run QuarTod on the stations and sensor data. We're prototyping that now how to allow users to hide and show the different quality checks. So that's a feature enhancement that'll be coming within the year.
Great. Thanks so much, Stacey and Brian. And since it's 1 o'clock, I'm going to go ahead and take back controls. And Bob, I see your question. I'll ask them directly, and we'll get back to you. I just want to remind everybody that you can find a recording of the webinar on SECOORA.org/webinar-series. And if you have any questions, please email Stacey or myself directly. And if we didn't get to your questions today, you will get those answered by the end of today. I do want to let everyone know that our next webinar is going to be March 27th at 12 p.m. Eastern. It's going to be Processes Investigating Exchange Around Cape Hatteras, Peach Project Update. It's going to be presented by Dana Savage from University of Georgia Skidaway Institute of Oceanography. Registration and info is coming soon. And I also want you all to be aware of 2 opportunities student opportunities that SECOORA has. We have the Zimbu Subramanian Ocean Scholars Award. Proposals are due March 15th at 5 p.m. and also the SECOORA 2018 Data Challenge, which proposals are due April 13th. And you can email me if you have any questions on those. And Stacey and Brian, once again, thank you so much for this webinar. And if anyone has any questions, please feel free to reach out to us. All right. Thanks, everybody. You have a great day.
Thank you.
Bye-bye.